All right, guys, the third conic section we're doing is called ellipses. Ellipses, kind of like a stretched out circle, or what you all would probably call it an oval, but it's called an ellipse. All right, an ellipse, here's a definition. Ellipse is a set of all points in a plane, so it's flat. The sum of whose distances from two fixed points called the foci. That's one of my favorite math words of all time. Foci, the foci, is constant. The center of an ellipse is the midpoint between the segment between the foci. So if you took, like they did right here, a string, and you put two pins here, two tacks, and do this oval, what would happen is every point on the oval, if you take that distance and subtract them, you get the same thing. So it's pretty cool. Yeah. Okay, here's what ours is going to look like. There's an ellipse. This is an ellipse where has, first of all, let me say this. An ellipse has two axes. It has a major axis and a minor axis. The major axis is the longest one, the one that's been stretched out. The minor axis is the smaller one. The foci always lay on the major axis, also known as the two foci. I love that word, foci. Is C away from the center. The vertices, these are called vertices. The vertices are on the major axis. These points up here and down here are called the co-vertices. So you got vertices on the major axis, foci on the major axis, and co-vertices on the minor axis. Okay, so an ellipse with the center of the origin where their major axis is horizontal. If that's the case, the equation is going to look like this. Let me tell you something about a squared and b squared. The a squared is the bigger number. The b squared is the smaller number. If the a squared is underneath the x is the major axis. In this case, that's what's happening here. It's stretched out on the x-axis. The vertices are plus or minus a, which is the square root of what's under there. The y-intercepts are plus or minus b, which is what's underneath the y. The way you find the foci all day today is we're going to go c squared is a squared minus b squared. You need to get that down somewhere. The foci, c squared, is always c away. See the foci right here? Plus or minus c. And the way you find c is do a squared minus b squared. If the major axis is vertical, look what happened to the a squared. Still got x squared first, still got y squared second, but the a squared and b squared switched. One thing I forgot to say in the last slide, the equation always equals 1. It must equal 1 to do this. So the a squared, again, is the biggest number, which tells you where the major axis is. Because it's underneath the y, the major axis is the vertical axis. Here the foci now. The foci are on the major axis, c away. Where does c? C squared is a squared minus b squared, always and forever, if it's an ellipse. Vertices are plus or minus a, like the word last time. The x-intercepts now are the b's, because that's what's underneath the x. The number underneath the x tells you where the x-intercepts are. All right, let's try one here. It says for the ellipse, find the vertices and the foci, then draw the graph. So first thing I'm going to do, this equation doesn't equal 1. So what I'm going to do to make it equal 1 is I'm dividing everything up there by 36. 9 goes into 36 4 times. 4 goes into 36 9 times. 36 divided by 36 is 1. All right, now, because the bigger number on the denominator is underneath the y is the major axis, which means the vertices are going to be at the square root of 9, which would be 0, and plus or minus 3, the two 3's. To find the foci, I'm going to do c squared is a squared minus b squared, which is the big number minus the small number. 9 minus 4 is 5, which means the two foci are going to be at plus or minus square root of 5. And they're always on the major axis, so they're going to be on the y-axis. So the way you would write that is you would say this. The foci, I'm trying to write that. The foci are at 0 plus or minus square root of 5. Okay, so to draw the graph, I go here. My center's at the vertex. I'm going to go 3 on my y, up and down. Those are my vertices. I'm going to go 2 on my x, both ways. Those are my co-vertices. And the ellipse looks like this. That's not very good, but that's what it looks like, kind of. The foci, square root of 5 is like 2 point something. So my two foci would be on the y-axis, on the major axis, up 2 point something, down 2 point something, like that. And there's your foci, right there. All right, now you know what's coming here. You got all this stuff in there. You're like, oh no, what is all that? And I'm like, I know, I get it, but we got to fix it. We got to make it look like it's supposed to. So I'm putting my x's beside each other, my y's beside each other. The 21 is going over to the other side. Now, the reason I didn't go ahead and skip space is because it's crazy 4 right there. Whenever there's a number in front of one of your squares, you have to factor it out. So I'm going to take out the 4. That will leave x squared minus 6x. Now I'm going to skip some space to complete the square. Y squared minus 2y, skip some space to complete the square. And I got negative 21. All right, so I'll take half of 6, square it. That's 9. Now here's what's weird. Even though I just added 9 to that side, I'm actually going to add 36 over here. Because when I added that 9, I really added 9 times the 4, which is 36. Be careful. Here, half of 2 is 1, squared, it's plus 1, so 1 plus 1. So here's what I have. I have 4 times x plus 3 squared plus y minus 1 squared equals 16 when I add all this stuff up. Now, don't forget what we need. We need this side to equal 1. So I'm going to divide everything up here by 16. Every single term by 16. So I get 4 goes into 16 4 times. So I get x plus 3 squared over 4. Y minus 1 squared is just over 16. And over here I get 1, which is what I wanted. Okay, so we got to find 3 things. We got to find the center, the vertices, and the foci. Okay, the center, first of all, is the opposite of what's inside the parentheses, just like the circle was. Right? The vertices, first of all, the y is the major axis again because 16 is the bigger number. So what the 16 tells me is the vertices are going to be plus or minus 4 away from the center. All right, not from 0, 0, but from the center. And because it's the y, it's going to be 4 up and 4 down from 1. So if I go up 4, it puts me at 5. If I go down 4 from 1, it puts me at negative 3. So there's my 2 vertices. Foci was the last thing we got to find. Foci is always c squared equals a squared minus b squared. It's the big number minus the small number. So I'm going 16 minus 4. That gives me 12. So c is plus or minus the square root of 12, which, by the way, is really 2 on 3. Now, again, that's how c is how far away the foci are from the center. Okay, so I'm going to say my foci would be negative 3, and then 1 plus or minus 2 on the square root of 3. That's where the foci are located. And then it says draw the graph. Not that we've done that much on this problem already, but it does say draw the graph. So here we go, last thing. The center is negative 3, 1, 2, 3, 1. Center's there. The vertices are negative 3, 5, which is 1, 2, 3, 4, up there. Sorry, my first point got messed up there. I went negative 1. There we go. Negative 3, 1's there. Negative 3, 5's there. And the other vertex is negative 3, which is down here. The co-vertices look underneath your x. It's a 4, which means I'm going to go 2 to the right and 2 to the left. Draw your ellipse. That's a little better than the first time. Your foci would be plus or minus 2 and square 3 away, somewhere around in there. So there's your foci. Sorry, that took a little time. All right, last slide here. Got to go backwards one time, as we always do. It says find the standard equation of the ellipse with these vertices and foci, then graph the ellipse. We won't graph it. We'll just find the equation. I think we can do that. Okay, so the vertices are on the x-axis. So, and also, let's find this. You got to find the center first too. The center's halfway between these 2 points. It's the midpoint of the vertices, which is going to be 0, 0. So my center is 0, 0, which means I can just do this. I can just do x squared over something plus y squared over something equals 1. Now the good news is I know what the something under the x is. The vertices are 5 and negative 5. And if you square that, it's 25. Remember, a squared, that's 25. All I need to know is what goes underneath my y. And you have to use what they give you. They gave me the foci. That's what I'm going to use. Remember, the foci equation for the third time is a squared minus b squared. The 3, the negative 3 is the c. So if I do 3 squared, that's 9. A squared I know is already in the problem. That's 25. So you just got to figure out b squared. Not b. I need b squared for my equation. So 25 minus what is 9? Everybody knows it's 16. So I'm going to take the 16, just plug it in right there. And guys, there's my equation. All right. Not too bad. Not as bad as the last one anyway. All right, we'll work on it tomorrow. Can't wait to see you then. Adios.